Thanks everyone so much for joining us for this event today on biochar and its potential as a soil amendment. We're really happy that everyone is here today. This event is hosted by the North Coast Soil Hub, which is a collaboration of RCDs and UC Cooperative Extension and NRCS and a lot of other partners. And we are based in the North Coast region of California. So this is the third workshop in a 5-part series on soil health technical assistance that is designed for ag professionals. We are super excited about our event today. We have some amazing speakers lined up. Before we get moving, we are offering CEU credits for this event. So if you are a certified crop advisor or a CPA or a CPS, please feel free at this point to take a photo of this QR code so that you can receive credits for today's workshop. I'll leave this up for another moment, and we will also be putting this back up again at the end so that folks can sign out. I'm going to be facilitating today's event. My name is Emilie Winfield, and I serve as the coordinator for the North Coast Soil Hub, and I'm based at the Resource Conservation Districts. And we also have Ashley Queetick here from Napa County Resource Conservation District, and she's going to be helping out behind the scenes, monitoring the chat and helping out with technology. So if you're experiencing any trouble either with this QR code or you have questions about anything, please feel free to send one of us a direct message or just put your question or comment directly into the chat. Okay, if you didn't get access to that QR code, please feel free to, again, send a direct message to Ashley or I, and we can put you on the sign-in sheet. So moving on to the core content of today's event, we're here to talk about biochar. And from my perspective, biochar tends to be really polarizing. I either meet people who love it, who want to sing its praises and use it all the time, or people who hate it, who never want to touch it. So one of the goals of today's event is to provide more balanced information about biochar. So we're going to be hearing an overview of current research, a discussion of potential risks and key considerations for utilizing biochar. We're going to hear about selection tools and how to evaluate biochar based on the characteristics from its feedstocks, how to interpret a chemical analysis of biochar. And finally, we're going to talk about how to systematically observe the impacts of new management practices if you're somebody who is experimenting with using biochar on your farm or ranch or thinking about utilizing it in the future. We have an awesome lineup of speakers here today, and I'm going to stop sharing my screen so that I can introduce our first speaker. Before we get moving, are there any other questions or any other housekeeping, any other issues? Okay, I'm not seeing anything, so I'm going to go ahead and move forward. Our first speaker that we have here today is Dr. Sanjai Parikh, who is an associate professor of soil chemistry at the University of California, Davis. His research focuses on the biogeochemical processes in soil and water that are critical for sustaining and improving soil, human, and global health. And Professor Parikh is a global leader in biochar research. He has conducted numerous studies to optimize biochar for agriculture, environmental, and climate change mitigation strategies. We are super happy to be joined today by Dr. Parikh, so go ahead and take it away. Thank you.
Hello, thank you, Emilie. Yeah, I'm glad to be here today and to share what I know about biochar and to go over and highlight some of the recent research findings that have been coming out from all over, researchers from all over the world, and to hopefully just paint a clear picture of biochar, at least from my perspective of how I view biochar. So, you know, alluding to the title here, clear as mud, and well, biochar is a interesting product because it's so variable, and so because of that, there's a lot of questions. And so hopefully today we can get through these and answer a lot of questions that you might have about using biochar as a soil amendment. So the first question is, what is biochar? And it's really like the charcoal. It's similar to charcoal that you might even use for your grill. But it is different in that it's a chemical conversion of this organic biomass that is done under high temperatures and limited oxygen. And so there's no combustion here, and that's the key because of the low to no oxygen that is in there. And it is being used more and more so as an agricultural and environmental amendment. So remediation or agronomic benefits. And of course, behind biochar is the idea of also carbon sequestration. And so, why did people start using biochar? Around 2000 or so, biochar started to appear more and more commonly. And in the last 20 years, nearly 25 now, it's really taken off. And there's just a huge amount of research. There's lots of producers, and this is globally. And when people were looking at the soils in Brazil, the Terra Preta de Indio soils, or these Amazonian black earth, they noticed that the soils there, which are generally of low fertility and high organic matter, that some of the soils that have received charcoal additions and historical charcoal additions had a higher organic matter content and were more fertile. And this kind of got things started for people thinking about what could biochar do for us in today's modern society. Now, when we look here, this is what I call the biochar wheel, and there's all of these different biochars here, and they're made from different feedstocks, and they look really different, right? And so one thing is that biochar is not a singular product. It's a range of products, and they can differ quite a bit from based on feedstock or how the biochar is made. And so some of the things that differ are the elemental composition, how much carbon, how much nitrogen, the pH that it has, things like porosity, surface area, cation exchange capacity, or water holding capacity are going to be quite variable. And as I said, this is a function of what the biochar is made from and how it's made. So there's going to be varied products that are available, and we shouldn't expect them to have the same outcomes. So it's basically here, biochar is made by taking these waste biomass. Wood is a very common one, but crop residues and manure, green wastes are also used. And they go through this pyrolyzer or gasifier, and in the process here, there is some potential. Well, there's bio oil that's generated, there's heat energy that's generated, and then there's also the biochar that's produced. And so this biochar can then be returned to the soil for various applications, and we get this added benefit, this co-product, depending on how someone's making the biochar, that could also provide some bioenergy. Now, the way biochar made is variable. You can make this in your backyard on a small scale. There's the more fancy industrial scale, and there's even portable units, which means that you don't need to transport your feedstocks to make the biochar. So there's an advantage there. And the more sophisticated the production method is, the more consistent the product can be. And so that's the advantage to these industrial scale, is that the temperature, heating rate, and the highest temperature and things can be very well controlled so that it's a consistent product. And depending on that temperature and whether it's fast or slow, the yield of biochar varies quite a bit. And so when there's the lower to moderate temperature, so we're talking temperatures usually sometimes as low as 3 and as high as 900. So often 5 to 700 degrees Celsius is going to be a common temperature. And so the yield varies. And so a lot of the biochar that's made for biochar is often made to enhance for optimal yield. And while biochar can be used at large scale, we also now see when you go to your local garden store that there's lots of options for biochar. And so there's different biochars that are available, and there's just a plethora of products, right? And so what the biochars, what's on the label of these is, it says it can grow more vibrant plants, reduce need for watering, retain nutrients, build soil fertility, improve soil health, microbial activity, reduce the need for chemical fertilizers. And the question is, does biochar deliver on these claims, right? That's what we want to know is if we use this, will we get these outcomes, right? One of the ones that's pretty unavoidable to get is putting carbon back into the soil, because biochar is a very stable form of carbon. And so when that goes in, it's going to stay there for a very long time. And the question is that does it deliver? The answer is yeah, sometimes. It depends on what biochar you're using and what you're using it for, whether or not these outcomes will be realized. And so I've already said it, and I keep on stressing this when I give talks, is that it's a really variable product. And so we know that different fertilizers are going to provide different amounts of nitrogen, phosphorus, potassium. We know that there's variety, and we can't just say vegetables, and it's not we don't know exactly what we're talking about. We have to talk about specific ones. And so this is an umbrella term, right? And it's based on how it's made. So with these variable products, again, we should expect variable outcomes. But what can biochar do is that the main thing, well, we have lots of potential benefits, right, of biochar production and use. And so we can use this for all kinds of good things. And the one that is, in my mind, the most straightforward is for a climate change mitigation technology, in that we can take the biomass that if we left it on the surface or just to land applied it, that the microbes would break this down relatively quickly and release carbon dioxide. So by doing this pyrolysis, we're creating a stable form of carbon, right? So that's like definitely there. And in fact, if we only cared about sequestering carbon, we could just make biochar and put it into a landfill and it would still do that job, right? But we want to make this a value-added product, right? So that it has other benefits. So the biggest area that biochar is used in is agricultural production for things like improving yield, enhancing favorable microbial activity, improving soil fertility. And so all of these are the main potential benefits we see for agriculture. It's also a really good amendment for specific types of soil remediation or environmental remediation with water. And because of its unique properties of high surface area and porosity and the chemical structure, it has a high capacity to bind a lot of organic and inorganic contaminants. And so that's another attractive use for biochar. Product substitution. So this can also be used for feed, bedding, potting media, industrial materials. There's a lot of research, and it's not as big of area as agricultural production or remediation, but that's also one option. Oh, that was a big leap to the wrong place. Sorry about that. Okay, and finally, then there's the waste management. Obviously, waste biomass can be a problem California has huge amounts of waste biomass from all kinds of agricultural activities, including nutshells and fruit pits. Also, we have these overstocked forests with a lot of dead and downed trees. Thinning those and using that material for biomass is great waste management. And then, as I mentioned, we can also get renewable energy. We can get bioenergy from this process if that's what we're also looking to do. But of course, the benefits are inconsistent. There's lots of variables, and there's even some possible drawbacks, but they can be avoided. I don't want to make people think that, oh, this is going to be bad. You just have to be careful, and then you can make wise choices. And the safe use of the materials, just like anything we do, the occupational health and safety should be considered. So what does biochar do? And if you asked this question 10 years ago, the answer would have been, we really aren't so sure. There's a lot of different variables, and the biochars have these range in physical chemical properties. We have different soils, cropping systems, climates, and all of that goes into it. And so Jeffrey has done a lot of meta-analyses. And so this 2017 paper was Biochar boosts tropical but not temperate crop yields. And tropical soils tend to be less fertile, low organic matter content, low pH. And biochar can help these. And so from the papers from around that time, there was often like there's a 50% chance that biochar is going to be beneficial, and almost a 0% chance, well, not zero, but very low chance that it's detrimental. But I think what's happened is that people realize, okay, that's great. 50% sounds bad, but what if we only start using it in the systems where we think there can be a benefit and not use it in really fertile soils that don't need anything, right? And so this is a meta-analysis that was done on, or more of it's a summary that was done looking at 26 meta-analysis published between 2016 and 2020. And so this is much more recent. And what we see here is that coming down and looking at some of the biomass yield, the physical properties, plant avoidable water, photosynthetic rate, microbial activities, all of these we tend to see that there's this benefit for biochar. On average, we get this positive effect, and we have less leaching of nitrogen, less N2O emissions, and then the amount, or so in terms of bioavailability of these toxic metals, is reduced by adding the biochar. And so there's been a bit of a shift where the evidence is showing more and more that biochar is beneficial for a lot of these agricultural systems. And so the authors wrote that our systematic review suggests that biochar use in agriculture has the potential to combine carbon dioxide removal with significant agronomic and or environmental co-benefits. And so if people are interested in using biochar, it's good to know that these really, thorough studies have gone through and determined that there is this high probability for benefits. When it comes to the carbon sequestration, well, we have this example here of sugarcane straw or sugarcane biochar. And basically, when we put the straw in, there's going to be microbial activity, high microbial activity, degradation of these materials with carbon dioxide release. And this says no net change in soil organic carbon. Well, maybe there could be some, I'm gonna, maybe not no, but it's not going to be a huge increase. But when we look at using the biochar that's put in there, we don't get that boost in microbial activity because this is not very good food for microbes. They can live on it and degrade it a bit, but it's not their favorite. It's difficult for them to access. So then this does start to improve organic carbon stocks in the soil, and it can provide those other benefits. such as habitats for microorganisms, increasing biodiversity, increasing soil resilience. And here's this conceptual diagram that was in a review paper by Joseph and Lehman and others. And they have just given this example of applying biochar every 3 years and applying litter, manure, compost every year. And this is just simply soil carbon content. And so it doesn't mean like the soil organic matter, because we wouldn't consider biochar to be that soil organic matter because it's recalcitrant carbon. But you can see that we have this change where the biochar will keep going up because it doesn't have the degradation that's occurring. Whereas when you add the litter, manure, or compost, so when you get very far out, you are increasing the carbon content, right? And so that's what I said about over here. This is no net change, but we are increasing it, but it's only a fraction of what the potential for biochar is to increase that. And so that's the sort of motivation between the carbon sequestration aspect. So in my lab at UC Davis, we look at biochar for all kinds of different applications. So there's agricultural. I'm a soil chemist, and so soil chemists are well known for their looking at contaminants. And so I do look at remediation of both organics and metals. And then it's so important to consider the health and safety and to use materials responsibly so we don't create problems, right? We want to be thoughtful and just go ahead and do it right from the start. So I'm going to go over a few of just some examples of our studies from our lab, and hopefully you can see the wide use of biochar. And so first one is, can biochar substitute peat moss in potting media? So peatlands are really important for us, right? They're our largest natural sink of carbon, terrestrial carbon. And the peat is harvested from places such as Canada, wherever the northern latitudes. When that material is transported, it's used high amounts in potting media mixtures, and that is used for growing starts. When you buy your starts from the garden store, there's a lot of peat moss in there. That peat moss is going to disappear once you put it in the soil in a relatively short amount of time. And so it's a great product for growing plants, but it's also not really sustainable from a carbon point of view. And so does biochar, can it be used as a replacement for peat moss as a recalcitrant form of carbon? And so we did this study using marigolds, and what we saw was that there was this benefit actually of replacing the peat with biochar. It wasn't, maybe it's better to say that there was no negative outcome. There's a slight benefit, but the outcome of having, this is all 0% biochar to 70% biochar. And so here, this is like our control, and we see that our dry shoot biomass doesn't really drop when we use the biochar substitute. And so the carbon savings on this can be really incredible. And here, this would be a greenness indicator, measure of relative chlorophyll content. And if we're talking about horticultural products, the appearance is incredibly important. And we see that there was this boost in the measured relative chlorophyll content as well. So a lot of potential here. Moving on to looking at several different biochars to just grow some lettuce. And so when we saw this over here, we have our no biochar. This happens to be just almond shells. And these are the different biochars. And we see that there was an improvement in lettuce growth in terms of the yield for all of these biochars, except for a almond shell biochar, which was, the plants didn't grow. Now, I want to stress that there is no almond shell biochars are bad. That's not true. Almond shell biochars can be fine. It's just that this one wasn't so good. When we used it later on after in a field trial, it was fine. So after it had been in the soil for a period and sort of acclimated, and maybe some of these compounds on the surface degraded, it was not negative. And so that was actually done in this field scale biochar trial, where we looked at tomatoes using 7 biochars in 2 different soils. And this was in Davis and Parikh, and both of these soils are known for being good agricultural soils. Okay, and so the Parikh soil is a sandier soil, and so it could benefit perhaps a little bit more than the silt loam in Davis. But we saw that there was no impact on yield, crop ripening, or plant nitrogen uptake when we applied these different biochars compared to the control. And in the soil, there was no effect on soil moisture, nitrogen content, and we saw slight changes in the pH and EC. And there was a slight increase in the potassium with the almond shell biochar. That was the one that didn't do so well in the plant growth, the lettuce trials. But we saw a similar result with the walnut shell biochar, which released potassium as well. And so what this is telling me is that, look, think carefully about where you're going to be using the biochar, because if your soil is a great soil, you're not going to get much benefit from adding it unless your goal is to sequester carbon. But in Parikh, we did see some benefits in terms of what we measure for soil health. And so we saw an increase in water stable aggregates, increase in microbial biomass, a decrease in these ratios, PLFA ratios, which are an indicator of microbial stress. So we saw a decrease in that. And there was an increase in the specific favorable microbial communities as well. And so while we didn't see those agronomic benefits, the benefits for the soil health were observed. And that was particularly true for the sandy loam soil. Looking at some of these same biochars, we wanted to ask the question, does biochar reduce nitrogen leaching? And so nitrate pollution of groundwaters is a problem globally, particularly it's definitely a problem in California. And so when we look at the ammonium, which is positively charged, and we can see here that this is, so basically this line is the influent concentration. So anything below that line shows that the ammonia is being retained by the biochar. And so some of these, particularly this almond shell 800, is retaining quite a bit of the ammonia. When we look at the nitrate, though, which is negatively charged, we see that you don't get a lot of that retention. This softwood at 500 retards the nitrate movement, but it eventually comes out anyway. And so biochar really has a high cation exchange capacity, but it has a low anion exchange capacity. So it's really good for retaining calcium and magnesium, potassium, but not so good for nitrate, phosphate, and sulfate. But we can actually modify biochars to bind nitrate and other anions. And so here's some data showing that these modified biochars in the hashed boxes here had significantly greater retention of, in this case, this is the ammonia, nitrate, and phosphate. So they were modified using different techniques to increase their anion exchange capacity. And so by doing this, there's a benefit for the overall retention of these nutrients. You can also create magnetic biochars. And so in our studies, we were able to reduce in cadmium and arsenic contaminated soils, 100% of cadmium and 35% of the arsenic added. And what's neat about this, which isn't going to work in all applications, is that because it's magnetic, Okay, I don't know how to get the pointer back. That's okay. There's a video, but for some reason I can't get it to work here. But so it's magnetic, so the magnet comes in here and we can remove that material from that slurry. One of the most promising things I see for biochar use is composting. And here's some pictures provided to me from Pacific Biochar, where they are doing composting mixes with their biochar. When we modify these biochars before composting to increase the anion exchange capacity, we can do that by using these organic polymers or some of these cations like magnesium. What we see is that compared to the control, which is the bottom line, the highest level of modification, the top lines here, are able to retain much more phosphate than the unmodified materials. And so by doing these modifications, we can improve the nutrient retention. And then when we look at using that as a soil amendment, we can compare the no amendment to these materials that weren't co-composted together to biochar composted with these modified biochars. The modified biochars increased the anion exchange capacity and greatly boosted the growth of those materials. So one thing to consider is that biochars can potentially have some negative outcomes. And first one is dust. It's a low density material. And if it's applied on windy days and in dry soils, you're going to get something like this occurring, which is very much not what we're looking for. But by just simply adding some moisture to that, what we can see is that the amount of biochar in the dust is less. And also the type of biochar makes a difference. In this case, the walnut shell biochar had much more of this in the dust because it wasn't able to interact and bind with the soil particles to keep it in as much. So it's just something to think about in terms of what the exposure is as you're using these materials. So when we want to apply biochars, we need to consider the safe application. And this is not difficult. It just needs planning and thoughtfulness. And so you need to select the right biochar, make sure you're not importing contaminants. You want to use biochar high moisture content. And so you can see here, this is biochar being applied at a high moisture content, about 50%. And here's one being applied at low moisture content. And so clearly very little dust here. Apply when wind levels are low. You can also apply it in bands where the roots are going to be and then bury that. That's one option instead of broadcast spreading it. And we always want to use our personal protective equipment. So at the end, biochar isn't a one-size-fits-all solution. That's definitely clear, that it's not going to benefit everybody, every agricultural field, every environmental remediation scenario. But it has really great potential for climate change mitigation and for targeted use in agriculture and environmental applications. So when we're thinking about agriculture, you have to think carefully about what the biochar is, what are its physical chemical properties, what's the soil type and climate, and then with that you can maximize the efficacy of biochar. And for some biochars, it might not be best to use it as a soil amendment. It might be better for some purpose, simply sequestering carbon, environmental remediation, or waste management. So when we are looking at our biochars, I think there's great promise in these modified biochars, and it's really critical, in my opinion, to develop biochars that have that are designed or tailored to have specific intended outcomes. All right, and then we can use those, and the efficacy of biochar will increase even further from what we've been observing. So with that, I'm gonna stop and I'm happy to take any questions.
Awesome. Thank you so much, Sanjai. We have several questions in the chat that I can get to those in a second. And I think, Gianna, do you have a hand raised?
Yeah, hi, my name is Jeannie. I work at the Center for Land-Based Learning, and we are actually doing a biochar and compost trial. Sanjay has been a consultant on that project. And one of the questions I get a lot, and I'd love to get your elevator speech response to this, is having to do with the life cycle analysis of the biochar. There was a recent article about this giant biochar plant that's being built in Canada. And apparently they're potentially going to be using feedstocks that are shipped all the way from Europe and Africa. And so my question is, obviously shipping feedstock materials has a carbon footprint. And I'm curious if there have been life cycle assessments of biochar and if there's any sort of, discussion about, what is the distance at what point does shipping the material not make sense with respect to the carbon impact?
Yeah, so that's an incredibly important question, and there are meta-analyses that do address this. I don't think there's anything that's been definitive that I've come across as this is the exact, but clearly local is going to be better, and also local use and local feedstocks and local use of the biochar. And so in Europe, it's not that uncommon for there to be these essentially big trucks that are mobile pyrolyzers that can go to a farm, create the biochar and leave it right there. And then of course now we have no transportation. And so thinking about it from that point of view, I think is important. And there was a biochar company that was it was in the US and was getting its feedstocks from China. And I just couldn't figure that out, so it is important. There are, we in our lab have been trying to get a LCA out from our research. It's been slowed down, but hopefully we'll have something out. Kristin, who's also speaking here today, probably, or I'm not going to say probably, she might also be able to address that question.
Awesome. Thanks, Jeannie, and sorry for misreading your name. We do need to move on here in a moment, but we might have time for one or two more questions from the chat. So there's a question, were there any other sources of nutrients in the study other than biochar or peat moss?
Yeah, so for the potting study, there was a Hoagland solution, which is a nutrient solution, which was used for fertigation. And then in all the others, so the field trials and the lettuce trials, the equal amounts of nitrogen were put in using fertilizer sources. So it came with other nutrients, but we normalized for nitrogen.
Awesome. Krista, you've got a hand up?
Yeah, I know that we're running a little short on time, but I was wondering if you could speak to any conversations with folks you've had in the industry or reflections you've had around potential unintended consequences of the adoption of practices like this. I'm thinking of things like, the adoption of micro irrigation actually causing, overall increases in water use across California, or, the use of upcycling of whey from industrial cheese productions actually causing more cheese productions because the whey is so marketable. So I was wondering if you could speak to anything how could biochar potentially be reinforcing some of the systems that are creating massive amounts of greenhouse gases in the first place?
Yeah, so, well, there's kind of two parts to that question, I think. And so one of them is that companies that I talk to, many of them are developing these, guidelines of how to apply it. And they're recommending methods that are going to reduce the risk of offsite transport from surface runoff or dust. And obviously we're going to avoid that, an inhalation thermal exposure. And as far as its greenhouse gas question, it kind of goes back to Jeannie's question, where it depends on, if we're transporting it farther, then yes, we are going to be having a negative, you use carbon negative technology, well, the carbon positive technology, if we're doing that. So I think that the producers are aware of this largely. Of course, some products are shipped commercially if they want to have large geographic distribution, and so that might not be. So if you're buying biochar at the store or you're getting it for somebody, I try to get it from somebody who's close to you, and always ask for the the chemical characterization to make sure it's not coming from construction waste that could have a lot of heavy metals in it or something.
Thanks.
Awesome, thank you. We do have more questions in the chat, but I think we'll try to save those for the end of the event if there's time. And we may also be able to answer a few of those questions in the chat, and some of them will hopefully also be answered by some of our subsequent speakers. So thank you again, Dr. Parikh. That was a great presentation. And I'm going to go ahead and introduce our next speaker, who is Kristin Trippe. She is a research microbiologist with the Agricultural Research Service, which is an agency within the USDA. She's based in Corvallis, Oregon. And her lab focuses on the effects of biochar on soil health and microbial community dynamics. And her lab also developed the Pacific Northwest Biochar Atlas. They have examined the role of biochar in rangeland restoration, mine reclamation, forest to farm biochar systems, soil water dynamics, and increasing agricultural yields, as well as broad spectrum studies focused on natural products and microbial biochemistry. So we're really happy to have you here today, Kristin, and I'm going to hand it over to you.
Awesome, thanks so much. I'm actually going to really quickly mute everybody so that we don't have any interruptions. And then I'm going to ask you to unmute, Kristin.
Okay. Okay, I'm going to share my screen, I think. Let's see. It looks like it's sharing. And then it should be in presentation mode now. So if hopefully someone can see my slides.
Perfect.
Looks good.
Looks great.
Great. So as Emilie mentioned, I am Kristin Trippe, and I'm based in Corvallis, Oregon. Today I'm coming from you from my mom's house in Tennessee. I'm visiting her. And after the presentation, I know that I'm going to get yelled at for changing the height of her office chair. So really looking forward to getting yelled at by my mom. Anyway, I want to thank Sanjai and everyone for inviting me, to Emilie for organizing. And I'd also just like to spend a moment to thank you for spending your morning here with me. I really appreciate it. And I hope that the work I'm about to show you can help you make decisions about biochar. I've been working in biochar for about a decade, and our efforts have been really centered on how to best pair biochar with soil deficiencies. Over the last 2 years, biochar is finally being recognized as a climate smart agricultural practice. So I'm excited to work with agencies to collaborate on expanding the use of biochar in agriculture and other sectors, whether it's forestry or field crops, or even other sectors like mine reclamation. So I'm excited to share this work with you, to hear your feedback, and to hear how you think we can change this tool in the near future to make it biochar more accessible and more effective for everyone. I'd also really quickly like to recognize the people who did the work on this atlas. Claire Phillips was a postdoc in my lab. She did a lot of work on the back end of this when she was a postdoc with me. She's now at the USDA in Pullman, Washington. Adam Lindsley, who's an associate professor at Oregon State University, designed a lot of the map interface. And then this work was initially funded by the Climate Hub and the USGS Climate Adaptation Science Center. So here's just a quick roadmap of today's talk. I'll give a brief introduction, talk about some existing tools that we can use to inform biochar-based decisions. And then I'll just move quickly into interpreting biochar lab reports, so that you can answer questions like, how much carbon am I adding to the soil? And we'll talk about common biochar conversions, and then talk about some brief economics, talk about our efforts to expand the current tools. And then if there's a little bit of time, I hope you can provide me some feedback and some ideas about how you think we should shape this tool moving forward. Okay, so we've all heard about how biochar can fill the need of agriculture in lots of different ways. Sanjai just talked about this, but what I want to say is that here in the Pacific Northwest, there's a great example because there's just this desperate need to utilize low value biomass to reduce wildfire risk. But there's no market for that. And so studies have shown that the production of biochar from low value wood sequesters carbon compared to things like burn and pile, and that the utilization of biochar increases soil health and crop yields. In other regions of the country, biochar can be used to help with the disposal of poultry litter. So for example, we can produce biochar from poultry litter, diverting those raw materials away from soils where they can cause nutrient leaching into waterways. The biochar from poultry litter can then be applied to soils, or it can be reapplied to poultry houses where it can reduce ammonia and improve animal health. Biochar can also be used as a compost additive, where it can be a sustainable replacement for other soil amendments like Sanjai just talked about, and can absorb toxins. These stories of sustainable synergies is what drew so many of us into biochar research. And as you can see from this graph, there has been a lot of research done on biochar. So this is just a Web of Science search that I do every few months on biochar. And you can see that over the last 10 or 11 years, we've had almost 30,000 articles, scientific articles about the use of biochar. However, the use of biochar hasn't been widely adopted. And this isn't surprising because when any new technology is developed, it takes a long time for adoption to occur. So for example, this is the technology curve. It wasn't developed for biochar, but it's been developed to think about any new technology. So let's just walk through it quickly because I think it really captures some of the problems with biochar. So, at the very beginning, when a technology is developed, there's a trigger that catalyzes the development of that technology. And then everybody just thinks it's going to solve everybody's problem. Soon enough, people figure out that there's problems with that technology and they enter the trough of disillusionment. And I would say that, 5 years ago, this is where we were at with biochar. We had all this information, but there wasn't any adoption. But then as we figure out how to work through some of those barriers, how to utilize the technology smartly, how to make changes to that technology, we can move through the slope of enlightenment to the plateau of productivity. Now, there's lots of barriers to biochar production, but what I would argue is that one of the main barriers is the very thing that makes biochar so cool in the first place, right? Is that biochar is tunable, that biochar is diverse, because the physiochemical properties of biochar are different depending on what they're produced from and how they are produced. Now here I've just taken 3 pictures of biochar. We've got a hazelnut biochar, a juniper biochar, and a poultry litter biochar. And you can see that they look really different on the macro level, but they also look really different on the micro level. So if we just compare the poultry litter to the hazelnut, and we look at one property of this. So this is what they call a proximate analysis, where they look at the different types of carbon within a compound, particularly the volatile carbon, the ash content, and the stable carbon. And you can see that they're really different for hazelnut and biochar. But as we increase the production temperature from 300 to 700 degrees, you can see that volatile or that proximate analysis really changes, where this volatile carbon in this green in poultry litter is changed to ash, but in hazelnut, it changes to stable carbon. Now, if we think about this in an agricultural context, it has quite the impact on how you might utilize this biochar in your field. So that ash content in the poultry litter creates a lot of liming value because it increases the calcium carbonate equivalents, and it also increases the amount of available P and K, so it increases the fertilizer value when compared to hazelnut. So when I get calls from growers asking me how to implement biochar practices, I don't have a right answer to give them because, like Sanjai said, biochar cannot be applied as a one-size-fits-all solution. Biochars vary in their physicochemical properties and the types of benefits that they can offer, and soils vary in their deficiencies. So the fundamental question, the answer to the fundamental question of what kind of biochar to use and how much to use is consistently, well, what are you trying to accomplish? What's the limiting factor in your cropping system or in your forestry system or in your mine system that you hope to ameliorate with biochar, and how much do you need to accomplish it? And to sort of skip to the punchline, what I would say is that in order to get the most benefit from biochar, or any soil amendment for that matter, is you have to identify your cropping goals. You have to identify products that can address those goals, and then you have to use those products at a rate that makes sense. And if this might sound familiar to you, it's because this sounds a lot like the principles of applying nutrients that we use in nutrient management, particularly the 4 R's, right? The right place, the right time, the right source, and the right rate, that are important for correctly utilizing fertilizer. Using biochar to improve soil health and crop yields honestly just requires similar thought. So what I'd like to start with is thinking about how to do that. And so again, you'll have to identify the right goals, find a product that meets that needs, and then find a rate that can match those needs. Again, that might sound like the 4 R's, the right source, the right place, and the right time. So to think about the right place, the NRCS recently released a tool within Web Soil Survey, which is different from Soil Web. This is a web-based server. And what it will do is it will tell you where in the United States is the best place to apply biochar based on data from the soil surveys. Now, there's a lot of caveats to this tool, so I'll go through those in the minute. But as I said, this tool is integrated into Web Soil Survey and is intended to provide baseline data on where to place biochar based upon those ratings. And again, these ratings are based sort of on inherent properties, including pH, CEC, organic matter, slope, the potential for flood, the potential for ponding, bulk density, and a slew of other inherent soil properties. So to get to this tool, what you would do is you can just Google Web Soil Survey, hit the start button, type in an address, select that area of interest on the map interface, and then from the map interface, you can go to the Soil Data Explorer tab, choose under Soil Health, Dynamic Soil Properties Response to Biochar, and what you'll do is you'll get a response that looks like this. So where you have these areas of green, red, and yellow, where you would have areas of, you would expect an excellent response of those properties that I showed you, whether it's pH or CEC or organic matter, to these red areas that where biochar is not recommended. So these sort of ratings are developed based on the properties of a corn stover biochar or on a manure-based biochar, which is not exactly necessarily the best biochar to apply to your soil, depending on where you are in the United States. I will also say that, as I said, these ratings are based on the properties of the soil series and don't take into account how previous management of that land may have impacted those properties. So I've pulled up soils on Web Soil Survey where it tells me that I may have an organic matter percentage between 0.5% and 1%, but the farmer's been adding compost year in and year out, and so their OM percentages look more like 4 or 5%. So while this tool is an awesome sort of first evaluation of how a land might respond, it certainly isn't necessarily the best tool. So what we wanted to do is understand how a biochar soil might respond to biochar. But the atlas I'll talk about goes 1 or 2 or even 3 steps further than this tool developed by the NRCS. And I'll take you through that in just a minute. But as I said, this is a really good first step. So what about the right rate? Well, nutrient management principles, again, use NPK values to estimate how much is needed to meet plant nutrient requirements. But unlike fertilizer, biochar labels don't come with an NPK or a liming value on the package. So in order to develop the biochar support tool, we needed to know what physiochemical properties of biochar look like. And to do that, we looked to the International Biochar Initiative and how they categorize their biochar. Now, currently in the United States, there's no federal regulations for labeling biochar, but to use, but in order for us to for us to sort of develop the ALIS tool I'm going to talk about, we looked to this IBI classification system. And because our decision support tool is based on this system, I just want to point out several aspects of it. This system, developed by the International Biochar Initiative, describes biochar agricultural impacts in 4 different areas. The first is a biochar's ability to provide long-term carbon storage. Second, its ability to provide plant nutrients, its ability to neutralize soil acidity, and the particle size of the biochar, which influences water retention and infiltration. This system provides a basis for comparing biochar so that a user can make informed decisions about selecting the most appropriate biochar for their application. So because it focuses on these 4 areas where soil impacts can be really robustly predicted, we decided to utilize it for the development of our biochar atlas. So this classification system gives a quantitative prediction of the impact biochar would have for a soil. So for example, when you look at fertilized class for this label, the number 4 shows that it has high concentrations of 4 nutrients in plant extractable forms: phosphorus, potassium, sulfur, and magnesium. And in this example, the subscript indicates that a 2-ton application of the biochar would provide sufficient extractable P and K to meet the demands of a corn crop, while a 5-ton application would provide sufficient sulfur and a 3-ton application would provide significant magnesium. Now, what this suggests that if you know a crop's nutrient requirements, and it can be any crop, it doesn't have to be corn, you can apply the right amount of biochar, perhaps in combination with other nutrient sources, to meet a crop's demand. Similarly, if you target pH, and you have a target pH that you need to adjust the soil to, you could calculate the amount of biochar needed to make that adjustment. Again, this framework is the sort of framework for our decision support tool, which uses an accounting approach based on the 3 R's that we like to think about in biochar: the right source, the right rate, and the right place. So let's take a look. Here's the tool. It's available now at pnwbiochar.org. And when you land on the homepage, there's a bunch of these cute little flip boxes that will help folks gain a basic understanding about biochar. It provides educational content, case studies, research highlights. You can find a producer, you can compare different biochars. But what I really want to spend time on today is this toolkit. Hang on, somehow I just lost my slides. There they are. But what I really want to focus on today is this toolkit that is accessible right here, where you can choose a biochar based on your cropping goals. Okay, so we're going to go to what we call the Soil Data Explorer. In order to get some information about our soils. And we can do this in one of 2 ways. If you're living in the Pacific Northwest, meaning Oregon, Washington, and Idaho, you can type in an address, click on the map, and pull up information about the soil series. Very similar to what you can do in Web Soil Survey. And what you can do is you can get information about the soil series, the predicted nutrient status, physical properties about your soil, like predicted texture, organic matter, moisture properties, CEC, And you can pull that up right here. It'll click through these 4 different tabs. However, most of the farmers who are using this tool are not in the Pacific Northwest, so we can't pull up that information from the map. However, if we click through, we can manually enter that information from a soil test. Now, in this case, we were using a case study from Maryland, and he had very detailed soil test results from a soil health benchmark study. So what I did was I entered these values about his organic matter, his fertility status, his acidity and pH, and then the texture of his soil. And from that, based on what he's growing, it'll give me some information. So here we go. Using that information, we'll pull up some information about carbon. And in this case, the farmer was adding a lot of compost and a lot of manure to his soils. And so you can see he had a lot of organic matter. I think his was 4%. Now, the fertility, of course, is crop specific. So from this tool, you can pull down a selection of over 40 crops. Most of them are Pacific Northwest specific, but I'll get to that in a second. It'll tell you what your nutrient requirements are for this crop. In this case, our farmer raises cattle, and you can see that he's very low in phosphorus and potassium. So here are the crops that are built into the back end of the tool. You can see that there's forage and seed crops, berry crops, and vegetable crops. So not only can you identify soil deficiencies with this tool, but you can identify crop-specific soil deficiencies with this tool. You can also learn about, again, depending on the crop, whether or not your soil is the right acidity, and you can learn a little bit about soil moisture. Now, armed with all of this data, knowing about our crop needs, we can start to choose some goals for potential application of biochar. If I had some, there we go. We can choose some potential goals for our biochar. Now, working with the farmer that I was talking about, he was interested in sequestering even more carbon above that 4%. So that was his first goal. His second priority was increasing phosphorus and then increasing water retention. And so clicking through, but there's a whole bunch of goals that you can choose from within the Biochar Atlas. You can choose anything from sequestering carbon to nutrient goals, increasing microbial activity, and reducing salts or binding heavy metals. So in this case, like I said, Keith was interested in sequestering carbon, increasing phosphorus, and increasing water retention. And so after he chose those priorities, the tool will look into our library and select biochars that make the most sense for that. So his first priority, sequestering carbon, identified biochars that are produced at higher temperatures, whether that's hazelnut shells or wood-based biochar. His second priority is increasing phosphorus. So it's going to choose biochars that have more of a higher ash content. So in this case, the poultry litter pellets. And his third priority, increasing water retention. That is really based off of particle size. And you can see it again pointed to these high temperature biochars. And so it'll sum up those goals. You can see that, 3 of these biochars meet 2 out of the 3 goals. And so if you were choosing, you would probably want to go to one of these wood-based or nutshell biochars produced at high temperatures. From that, you can choose a biochar, choose an application rate, unit. You can also do this in tons per hectare, and it'll give you, or megagrams per hectare, and it'll tell you how much stable carbon you can expect to add to your soils if you add anywhere from 0.5 tons per acre all the way up to 10 tons per acre. Okay, so I'm just going to move away from the Atlas for just a few minutes, and I want to go over a typical lab report that you might get from a biochar producer talking about the properties of their biochar. Now, some of the 2 most important things on one of these lab reports are going to be the moisture content of the biochar and the bulk density of these biochar, because both of these are going to be important for understanding how much biochar you're adding as opposed to water you're adding, and doing just volume to weight ratios. So here's a typical lab report, and you can see that there's a lot of information listed here about the physical and chemical properties. Some of these are really important and have a large impact on soil fertility and soil carbon. Others are just good information. Because if you're going to use conservation practice standards for biochar, which I'll get to at the end of my presentation, it has to meet regulatory thresholds for metals. But today we're just talking about a few agronomically important features. Again, two that I wanted to focus on is moisture content. That's usually one of the top numbers on a lab report, and then bulk density. Using these values, it's pretty straightforward to calculate how much carbon you're adding to a soil. Specifically, you need to look at the fraction of organic matter or organic carbon in the biochar, the moisture content, and the application rate. So using the value on this lab analysis, you can see that it'll give me a organic carbon ratio of a percentage. It'll also tell me the total ash within this biochar. So using the value on this lab analysis and assuming you're amending at 10 tons an acre, we just simply multiply the organic carbon fraction by the decimal percent of water in the application rate, to, in this case, to get 4.6% carbon. Again, this goes back to this proximate analysis that I talked about, where you've got a specific amount of ash, volatile, and stable carbon within this organic carbon itself, right? So the H to C ratio is really important because it's going to tell us how many atoms of hydrogen are for every atom of carbon. And this is really important to tell you how stable your biochar is. So if you have a low H to C ratio, that means that you have more of those really stable aromatic ring structures in your biochar that's less likely to break down. Whereas if you have a high H to C ratio, it's more likely to be eaten up by microbes. So if your sort of goal in adding biochar to your system is stable carbon, having a lot of carbon in your system, you're going to look for something that has a low H to C ratio. If your goal is to add fertility, you're probably going to want something with a higher H to C ratio. And here's what I'm talking about with these stable rings. So if you have a low H to C ratio, it's probably going to look something like this, where you have very few functional groups on the outside of that carbon ring. Whereas if you have a high H to C ratio, you're going to have more functional groups, which are capable of interacting with other compounds in the soil. This material is rather inert over time. Okay, so again, how much carbon are we adding to the system? What's the rate of application? What you want to do is you want to take this HC-org ratio, which is just essentially your organic carbon. You want to multiply this by 1 times your decimal percent of water to get your times your application rate. So in this case, if you've got 0.83% carbon, you're multiplying it by 1 minus the moisture content by the application rate, and you'll be adding, in this case, 4.13 tons of organic carbon per acre. Again, the percent carbon added depends on the application scenario. So what do I mean by that? So if you've got a vineyard and you're only cultivating half your field, you need to take that into account. And you can do that based on an acre furrow slice. You can do that based on if you're cultivating deeper, but for common conversions in biochar, we usually use an acre furrow slice, which is considering that you're cultivating 6.7 inches deep into your soil, and that's about 1,000 tons. 1,000 tons of soil is the weight of an acre furrow slice. So that's how we come up with these sorts of calculations. For soil fertility, wanting to know how much you're offsetting your fertilizer needs by adding a bunch of biochar. Again, your lab report can inform that answer. The values of NPK on these reports are reported in parts per million or in milligrams of biochar per kilogram of soil. These values shown on this report are pretty low. I think they're 10, 36, 85, and 460 for nitrogen, phosphorus, and potassium, respectively. A carbon that has 50% moisture content has half of this fertility value. But farmers don't tend to think about parts per million or milligrams per kilogram. So we need to convert that to pounds per acre. Again, I'm just gonna like do a multiplication, use a conversion factor that changes my units from mgs per kilo or ppm to pounds per ton. And that conversion factor is 0.002. And then you just multiply the weight values by the application rate by this conversion factor to come up with how many pounds per acre for your ton for your soil. So in this case, we've got about again an NPK value, wet weight of 5 mgs per kilo, 2,230, which is down here. And then you can see the wet weight. If we use that conversion of 0.002, it comes to adding about 0.1 pound per acre if you're adding 10 tons of biochar. So not a lot of nutrient value in this particular biochar. And I'll share a conversion calculator with the organizers that you can use to run one of these reports and to make these calculations. Again, to go from this milligram per kilo to pounds per ton, you just need to multiply it by 0.002. Okay, for neutralizing capacity, what about lime? Does adding all this biochar help offset lime costs? If we look at the analysis, it shows two values. It'll show a value in pH and a value in calcium carbonate equivalents. And you can see that right here is the liming value of the biochar. I would pretty much ignore the pH values on these reports, because what's really important is how much they act like lime, and that'll be reported in the calcium carbonate equivalents, not in the pH. So let's look at the calcium carbonate equivalents. Here it says that the calcium carbonate equivalence is 2.4, 2.5%, meaning that it's 40 times less potent than agricultural lime. But it's still something to consider, especially if your calcium carbonate equivalence numbers are higher. So to calculate how much neutralizing power we're adding, we're just going to take the decimal percent of the liming equivalents. We're going to multiply that by the application rate, take into account the moisture content. So if in this case, if we add 10 tons of biochar, we're adding about 0.12 tons of a lime equivalence, which isn't a lot. But if you're applying a biochar with a higher ash content, it really could offset your lime budget. Now, again, there's a lot of data contained in this report. Many of these we're not going to use to determine how biochar reacts in the soil. But values like metals, and I believe that Sanjai said this, are really important to quantify and understand so that we don't contribute to heavy metal pollution in agricultural systems. Now, really quickly, just to show you how to calculate how much volume of biochar is in a ton, we can use the bulk density measurement. Here, the bulk density the lab report says that the bulk density is 11.3 pounds per foot. To change these values to pounds per cubic yards per foot, what we need to do is just multiply the value by 27. From there, we can switch this to tons by dividing by 200 pounds per ton in order to get that using to figure out that in this case, a biochar with 11.3 pounds per square foot would be 6.6 yards per ton, or 301 pounds per yard. Again, this is a lot of information, and this is thinking about dry biochar. If we use this wet conversion, we need to again go to this moisture content, divide by 1 minus the moisture content to get that we would need 313 pounds of biochar in a yard, and then 3.3 yards per ton. So all this information is interesting and useful, but unless a grower can make the economics of biochar work, nobody's going to apply it. To help farmers make this decision, going back to the atlas, we developed some economic tools to help farmers make that decision. So we can use this cost benefit tool to determine if adding biochar to improve the growth. And here we're just going to go with potatoes makes economic sense. With the cost benefit analysis tool, we just enter numbers that we can either get from survey data that you have from your own farm or that you just make up. In this case, I got these numbers from the National Ag Statistics survey, and we used 500 pounds of biochar per ton as a biochar cost. We assumed that potatoes were $9 a hundredweight, that our yield per acre was 600 hundredweights per acre, and that by applying biochar, we would have a 5% increase in yield. We also assumed that we wouldn't have any change in input and that benefits added would last 5 years. And so if you do that information, here we're adding 1 ton per acre. Here's the cost of the biochar, how much the transport and the application would be, the crop value, which I just went over, the expected change in yield, the changes in other crop inputs, you can add that in. And then you can see that in this case, the calculator says that the farmer would have an $851 gain over 5 years if he applied 1 ton per acre and had a 5% increase in yield. This is more fun to play around with, especially if you know the price of your biochar and the net value of your crop. So that makes economic sense in potatoes, but would it make economic sense in a crop that had a lower commodity value? So what about wheat? What about grass seed, which is very popular where I work in Corvallis? Those numbers usually don't pencil out because the price of the commodity is just too low. However, the NRCS has recently adopted the 336 conservation practice standard. This practice standard, which is available through the NRCS in, I think, 38 states now, potentially subsidizes the cost of biochar. These were these sort of cost schedules are things that were last year's schedules, so they're no longer relevant. But you can see that the subsidies for adding these products, including compost, including biochar plus compost, and including biochar, are pretty substantial and can offset the cost of that amendment. So there's a lot of questions about how to implement this 336 conservation practice standard. And in response, the NRCS asked us to expand the Pacific Northwest Biochar Atlas to the whole United States. So to do that, we're expanding that map function at the beginning. We're also expanding the biochar library. We're putting in locally produced biochars. We're testing biochars from biochar producers from all over the country, providing people with information about how to apply biochar, and then adding all these calculators that I went through to the biochar atlas. We're also training producers, we're training conservation planners, training farmers and technical service providers to make good biochar-based decisions. So USDA, we've got about 20 collaborators that are working to characterize biochars. So if you're a biochar producer and you have a biochar that you'd like to include in the atlas, you're welcome to contact me. Washington State, Jim Amonette is developing an LCA tool, and this is relevant to the person who asked about LCAs. So within the atlas, you'll be able to punch in where your biochar came from, how it was made, what it was made from, and it should be able to add it should be able to provide you carbon sequestration estimates and greenhouse gas consequences of adding that biochar. Oregon State University is going to be helping us with web development and model implementation. And then USBI, which is the US Biochar Initiative, is going to be doing outreach to farmers and to biochar producers. We're also developing fact sheets with USBI, and then American Farmland Trust is again working with farmers and doing in-reach to the NRCS to provide training and workshops. This work is ongoing, but should really ramp up in the next few months. So if you have questions, if you want to go to the Atlas and play around and have feedback, to me, I would love to hear how we can improve it to work further. I also want to do a quick shout out for other tools that are available right now on the web. We recently released 2 fact sheets on biochar application in Biochar. These are general application sheets, fact sheets that apply to the whole country. Those are available at the USBI Learning Center, which is right here. You can just Google USBI Learning Center. There's a lot of good resources, including other fact sheets on how to use biochar and compost, how to use biochar and stormwater, manure management. There's a lot going on there. So I'd like to point you to that. New York Soil Health also has a lot of good information on biochar. We're also in our lab developing FAQs and other tools as well. So if they at this session, I would needs are of that can start passing those barriers to. And with that, I think I might have just 1 or 2 minutes for questions.
Awesome. Thank you, Kristin. That was amazing. It's so great to hear about all those tools that are available. I didn't realize that the Biochar Atlas would be expanded throughout the country, so that's really exciting. Yes, we have a couple of questions in the chat. If there's any questions out in the audience, feel free to raise your hand. We did have a question in the chat about application on a vineyard. They are practicing no-till and wondering about what the impacts would be of applying biochar to the soil surface and then, say, roller crimping. Yeah.
So we've done a little bit of this. We added a really crazy amount of biochar to a vineyard in Southern Oregon. I'm happy to share that. If you want to email me, I can put my email in the chat. I'm happy to send you that paper, but we did 8 tons an acre in row. And we used just a handheld rototiller to just minimally incorporate it. And we saw no negative impacts either in the soil or on the wine, which was really important. So although we didn't see a huge increase in yield, we did see a huge increase in soil carbon. And so really cool. And the fact I didn't see any negative impacts on the wine was also, I think, a good outcome. There have been studies in California. Dovetail Industries have done quite a bit. Harry Groot has done quite a bit of work down there looking at biochar and wine, and they've seen some really good results. But when they apply it as an amendment during the replanting of vines. So I don't know that any of their results are really going to address your question about what it looks like in terms of yield response when you apply it to existing vines.
Right. Thank you. I think we need to move on, but we'll have a couple more minutes at the end of the event for additional questions if folks have questions that have not been answered yet. Thank you so much, Kristin. That was a great presentation. We are so happy that we got to hear from you today. So thank you for joining us. Okay, if folks have additional questions for Kristin, please feel free to put them in the chat and we can try to get to a couple more at the end of our event. We are going to move on to our last speaker, Daniel Geisseler. Thank you again, Daniel, for joining us today. We're really happy to have you. He is a cooperative extension specialist in the Department of Land, Air, and Water Resources at UC Davis. And his research and outreach focuses on nutrient turnover and plant nutrition in agricultural systems. And he is interested in the effects that different management practices have on nutrient use in California crops and how nutrient use efficiency can be improved, particularly with nitrogen. Okay, I'm going to hand it over to you. Thanks, Daniel.
Thank you very much for the introduction and for having me. And good morning, everybody. So I was asked to give a short presentation about systematically observing impacts of new management practices. And in my presentation, I will focus on on-farm trials, plant tissue analysis, and soil nitrate analysis. And I won't be able to go into too much details because of that, I prepared a slide with some very good online resources where you can get much more information about these topics. So basically my presentation is just a short teaser, and then you can go find your information you need online too. So let's start with some thoughts about on-farm trials. And when I prepared the slide, I was thinking about an on-farm trial where you want to compare different management practices or different treatments. Let's say you want to compare what's the effect or what's the difference between a plot in the field where you apply biochar and a plot where you don't apply biochar. Or if you apply biochar to the entire field, can you, what is the effect when you reduce the amount of fertilizer applied compared to the normal application rate? So if you have an on-farm trial with different plots, the first thing that's very important is you need to select a uniform field or a uniform area within a field. And you can check for uniformity. I think the first step would be to have a look at soil survey data and see, is it based on that, is it uniform? It's always a good idea to talk to the grower and see whether they observe differences when they manage the crops in the crop yield or how the crops grow. If a crop is growing, when you're there in the field, you may see some differences, or if there's nothing growing, you may see differences in soil surface. If you have some conflicting information, for example, soil survey data tells you, yeah, there's a gradient in the field, but the grower tells you, no, I really don't observe anything in my crops, then it may be a good idea to take some soil samples from the different areas and see, is the soil really different or not? It's not always possible to have different plots in a field. For example, if you want to test nutrient application rates in a fertigated field, especially if it's subsurface drip irrigated, it's really hard to have different treatments within a field. So an alternative could be to select paired fields, two different fields with similar characteristics, similar soil properties, similar crop rotation and yield potential, and then test the treatments, each of the treatments in one of these fields. There's certainly a bit more variability, but sometimes that's a good alternative. Then you have to make a decision about the treatment plots. How big should the area be where you apply your treatment? Let's say your treatment is a biochar application. Ideally, the plots are big enough so that all the management practices can be done with the available farm equipment, so then you don't have to go in and do everything by hand. It's not always possible. Sometimes you may have an expensive amendment, or if you use different biochars, not all of, if you use biochars that are not commercially available, you may not have large amounts, so you may have to have smaller plots based on the availability of the material. Or sometimes you need to apply the material by hand because the equipment isn't available, so then you probably don't want to apply biochar on a 20-acre field. You will choose a smaller plot for your trial. Also, if you expect with one of your treatment that there may be a yield decrease, again, it would be prudent to have a smaller plot so that the risk for the grower isn't that big in case there is really a lower yield with a treatment. It's also important within your plots, you need a border area surrounding your plot. The border area is really the area that may be affected by the treatment that surrounds your plot. And so then you would not take measurements in your border area, but focus on the central part of your plot. And how big that border area is really depends on the situation. If you, let's say you band apply a high moisture biochar, then the border area maybe one 6-foot bed may be big enough. If you broadcast a low moisture biochar on a windy day, then of course your border area needs to be much bigger for the control where you don't apply biochar. Then another question to answer is, should you have replicates or not? And that really depends on how you want to use your data, what you want to do with your data, also who is your audience. So whenever you want to do any statistical analysis, you need to have replicated plots. Just one plot with biochar, one plot without. You will not be able to statistically analyze it. Sometimes for a demonstration trial, that's good enough, because you want people to just see the difference side by side. But if you want to do statistical analysis, you need replicates. And you can either replicate within a plot by having 3 or 4 plots with biochar, 3 or 4 plots without, and then take the measurements in each plot separately. It's also possible to conduct a trial in different fields and or several seasons. So then in every field you would have the same 2 or 3 treatments, and each field will serve as a replicate. That means you would have more variability, so it may be harder to detect differences. But if you do an applied research trial, that may be more interesting, especially if your audience are the growers in an area and you want to show them, yes, biochar is a good practice. By just having one field site, many growers may tell you, oh, but my soil is different, so how does it work in my soil? Or I have a different crop rotation. So by doing it in a larger number of fields, that may strengthen your conclusion. Then a few more considerations when doing on-farm trials. My first advice would be, keep it simple. Don't try to have too many treatments, because the more treatments you have, the more small plots you have within the field, the bigger the risk of something going wrong, or a management practice, or somebody who does management forgets that you have your plot there, and you may lose your trial, or at least part of your trial. So the simpler it is, the bigger the chances that you will be successful in comparing your treatments. Good communication with the grower is also very important. It may not always be enough. In a few years ago, we had a trial in a nitrogen trial where we had very good communication with the grower, and he was willing not to apply fertilizer to one part of the field. But by the time fertilizer was applied, he wasn't available. Somebody else applied the fertilizer, and that person didn't know about our discussion and didn't know what these flags in the field actually meant. So the fertilizer was applied throughout the field. So even when you have very good communication with the grower, sometimes things can go wrong. And then also, before you start your trial, really think about what are the questions you want to answer, what are your hypotheses, and think about, okay, that's the data I want to collect, and can I really answer these questions? So that's something you need to do before you set up the trial, before you take samples and analyze these samples, just to make sure at the end of the season you can actually answer the questions you want to answer, or address your hypothesis. And then if you're interested in changes in soil properties, it's always a good idea to take soil samples before implementing the treatments, just to know what are the baseline values. At the end of the season, of course, your main objective is to compare your different treatments, but it's always good to also know, how did soil properties change compared to the beginning of the treatment. So did they go up? Did a specific measure go up, go down, or remain at the same level? And then you can also compare the different treatments, how the soil properties were at the end of the season. And that's probably more, the next point is more for nutrient management trials but let's say you apply biochar and you think that because of the biochar, you need to apply much less fertilizer. If you want to apply fertilizer by much, growers may not be that comfortable. So one solution would be to reduce your fertilizer or just general inputs in several steps over several seasons. So instead of reducing your nitrogen application rate by 100 pounds, reduce it by 30 pounds, observe what happens next year. If you don't see a difference in yield, you can reduce it by more. And so slowly approach the ideal application rate. Or the same would be true if you, with management practices, probably change one practice at the time that you can really see what happens. Of course, that's not always possible. For example, if you switch to organic practices, then everything needs to be changed at the time. Then also important, even though you may be mainly interested in the effect on yield, monitor the field throughout the season. Go out, have a look at the plants and take samples, either leaf tissue samples or soil samples, to really see during the season what is changing. And just 2 slides about plant tissue samples. They are, for most growers, taking plant tissue samples is more during the season is more popular than soil samples. So growers normally have a lot of experience in taking plant tissue samples and analyzing them. And they're a really good tool to monitor nutrient availability to the crop. Leaf tissue samples allow you to detect nutrient deficiencies at an early stage, long before the nutrients actually become, or deficiency symptoms are visible, but they are not sensitive to excess nutrient availability. And it's also important, especially when you work in orchards, that you continue monitoring the field for a few years, especially if your treatment is a reduction in nutrient availability, because orchards, the trees may store nutrients in the perennial tissue. So if your application rate is too low, they may supplement it with their reserves. But after 2 or 3 years of suboptimal nutrient applications, you would actually see, or these reserves are used up, and then you would start seeing a difference in yield. So especially in orchards or vineyards, it would be important to continue monitoring for a longer period of time and not conclude after the first year, okay, reducing the application rates is good enough and we are done here. And it's also important when you want to compare your plant tissue analysis with published values to know that these values depend on the growth stage and the plant part or the organ sample. So you need to check first when should samples be taken and which organ should be taken from a plant, so that you can compare your values with book values. And you can find book values in the Western Fertilizer Handbook, but also online. For example, our California Fertilization Guidelines, you can find them for about 30 crops grown in California. When you're just interested in comparing treatments within a field and not necessarily whether that's sufficient or deficient, you just want to know, are there differences between treatments, then sampling time is less crucial. Then it's just important to take the samples at the same time, and then you can compare them, the 2 treatments. For soil samples, just I've prepared one slide for a soil nitrogen analysis, when it may be useful to take soil samples during the season. Let's say you want to promote the use of biochar or some organic amendment, and your objective is not really comparing it with a treatment without biochar or that amendment, but your goal is to adjust the nitrogen management to minimize the risk of decreased yield, but also minimize the risk of nitrogen leaching losses. So you just want to get it right. And so that may be a bit difficult because you don't know exactly what will be the difference due to your biochar or your organic amendment. So one way to do that would be in crops where you can actually split the application, so do several applications during the growing season. Before you feel it's necessary to have another application, take a soil sample and analyze it for nitrate nitrogen. You can either send it to a lab or use a quick test on the farm. When you have a 1 foot, when you take the sample from the top foot and your results is in ppm or parts per million of nitrate nitrogen from a lab analysis, you can multiply it by 3.5 to 4 to convert it to pounds per acre. So let's say a lab analysis tells you it's 20 ppm nitrate N. That means there are 70 to 80 pounds of nitrogen, plant available nitrogen there per acre. And nitrate is the main form of nitrogen that's plant available. And many trials have shown that even during the phase of high nitrogen uptake, crops hardly ever take up more than 5 to 7 pounds of nitrogen per acre per day. So if you have a pool that's 70 to 80 pounds, you know that will be enough for the next 10 or 14 days. So in that case, if you have 20 ppm of nitrate N or more, you really don't need to fertilize yet, but you should come back in 10 or 14 days and repeat the procedure. If you have lower nitrate nitrogen N, then you could just apply the amount of fertilizer to get again to that 80 pounds per acre. That way you know, okay, now there's enough nitrogen there in the field for the next 10 or 14 days. And then you can go back and check, is there still, or how much is still left? Is it really necessary to apply more fertilizer? So that would be a way, if you have a treatment, your goal is to manage nitrogen efficiently, go in and take samples regularly before you apply fertilizer to determine whether you actually need or how much is needed. These are the things I have prepared. There are a lot of resources online that can provide you a lot of very interesting information. I've been working on the California fertilization guidelines for a while and maintain and update them. So there you can find a lot of information about nutrient management, but also leaf and tissue analysis and soil sampling, soil survey data. There's a link here, Biochar website. It's the same data from the NRCS soil survey. My opinion is it's a little bit user-friendly, but you can check both sites. And then STAIR has also published a really nice publication on how to conduct on-farm research. That's a PDF version is available online, so that provides you much more detail than I was able to give you today. And if you're interested in doing a nitrate quick test on your own without having to send a sample to the lab, there are also very good information, there's very good information online available how to do it and how to interpret your quick test results so that you can do the analysis on your farm without having to send a sample to the lab. So, thank you very much for your attention, and if we have time for questions, we'll be happy to answer them.
Thank you so much, Daniel. So much great information about conducting field trials and working with growers. So thank you so much. And we will also share out with everyone the resources that Daniel put together for us. Okay, we have a couple of moments left, so we've got time for just a couple of questions. I think there are some unanswered questions that may be a little bit further back in the chat, but thank you to the folks who have put some answers in the chat. We did have a question. This might be more for Sanjai or Kristin, but Danny is wondering, is it possible to burn wood chips and have a useful result? So I think the question is about using wood chips to create biochar. And Danny, if you're in the audience, please feel free to chime in if I'm not understanding your question right.
All right, well, I can just first say that when we make biochar, we want to differentiate between burning and pyrolysis or gasification. So if you burn it in, open fire, you're going to have a lot of ash, and you're not going to sequester as much carbon, and it's not going to provide the same potential benefits. So, but wood chips are usually what are used for making biochar. Usually the wood is chipped first, and so yeah, that's fine to do that.
Great. Thank you. We had some questions, and I think Kristin also, you mentioned in your presentation about the NRCS conservation practice soil carbon amendment that is in various stages of adoption across many states in the US. And thank you, Karen, for your comment in the chat that the soil carbon amendment conservation practice will be officially adopted very shortly in California. If there are folks from NRCS on the call who want to speak up and share about that conservation practice or the adoption of the soil carbon amendment, please feel free. Okay. We have a question. Can you elaborate more on how biochar affects the soil nitrogen levels? Does biochar bind to some forms of nitrogen? Does biochar have a positive or negative charge?
So I guess I can chat about that quick. So the way that biochar reacts with nitrogen is that it's not sort of the typical way you think about it in a C to N ratio, where if you add something that has a really high carbon, then the sort of immobilization of that carbon through microbial mineralization is not necessarily going to suck nitrogen in the same way that adding like straw or compost would be. And that's because a lot of the carbon in biochar is really recalcitrant. And so as opposed to sort of a microbial immobilization mechanism for, holding on to nitrogen, rather it's an absorption mechanism. And so it will absorb nitrogen and then release it over time. I think I haven't seen a lot of really good decision support frameworks that say, if you're going to add a biochar with this much carbon, you need to add this much nitrogen to offset it. I think that it's something that's really hard, to be completely honest, for land managers to figure out. But if I was doing it and I had my own lab equipment, what I would probably do is add the biochar, let it react with the soil, and then look to see how much available carbon, or sorry, how much available nitrogen was in that soil. Sorry for the non-answer, but.
Great, thanks, Kristin. Miguel, you have a hand up.
Hi, thanks to the speakers for the great presentations, really appreciate it. I am thinking about folks that want to produce their own biochar on site. I have read somewhere, I don't remember where, that it is not advisable to add the biochar that is produced on site directly into the soil. Thinking about the high cation exchange capacity of biochar, I've read that it might take up nutrients already present in the soil, and that is rather recommended to mix it with compost, quote unquote, to activate the biochar, I think I've heard being called, just so that when you apply it to the soil, it is not going to create any imbalance with the nutrients already in the soil. So I'm curious if any of the speakers have any insight about what a farmer that is producing their biochar should do to the biochar before adding it to the soil. Thank you.
That is a great question. And I would absolutely recommend that people post-process their biochar before adding it to the soil, either by blending it with compost, with a nitrogen source, whether some people use urine, some folks use manure, some folks use, again, compost. I would, and I'll put this in the chat, I would recommend Debbie Aller, who is a extension specialist with New York's State Soil Health. She and I and some other folks have just written an application guideline. A lot of that information is in that guideline. So I'll post a link to that in the chat in just a minute. But I really recommend that as sort of a just to read it before you add biochar to your soil to sort of give you a nice background, and it's got some really nice references in there.
Thanks, Kristin. We have a similar question. Can biochar applications have a negative impact on soil applied herbicides? Negative meaning that it may tie up the herbicide such that the effects are reduced. And I just see that there's an answer. Yes, biochar will bind most pesticides. If it is a soil applied herbicide, it will reduce its efficacy.
Yeah, that goes for anything that you'll be putting onto the soil. Biochar is pretty much across the board a high absorption capacity, so it kind of ties in with the kind of exchange capacity and what's going to be retained and requiring additional fertilizers, because it is kind of this sponge and it's going to suck up those nutrients. But yeah, any organic compounds that go there have a high, typically high binding affinity for biochars.
Great. And another note in the chat, there's also a lot on YouTube. It's great. Okay, this is the last question that we have time for today. Would anyone like to speak to the potential uses of biochar for water quality mitigation, specifically for pesticides?
Yeah, it's basically the kind of the same answer as the prior one. If you have some sort of biochar filtration system, it's going to have a high binding capacity. Obviously biochar is not activated carbon, but you can think about it as a similar product. Activated carbon is used specifically to tie up contaminants and remediation. And so wastewater treatment, there is biochar used sometimes, and it's effective. And actually it's a good way. If you have a lot of undesirable contaminants, they'll bind those. But if you're just trying to get out nutrients, it can be a really good way to recycle those nutrients and essentially load that biochar with nutrients and then use that as a fertilizing material later.
Great. Okay. Krista, I see your question in the chat. That may be something that we can send out with the resources. We have a question about how much additional fertilizers or pesticides are needed to offset the absorption. So we can, maybe Sanjai or Kristin, we can get an answer to that and send that out along with the resources that we're going to send out after the event. I've just got a couple of announcements before we thank our speakers and get out of here. I am putting in the chat a link to an event survey. If you have a couple of minutes following this event, we would really appreciate you taking the time to provide us with some brief feedback so that we can improve our future educational events. We will be hosting 2 more workshops as a part of this 5-part series that are happening later this year. So if you've registered for this event, you should receive information about those events. Those will happen this fall. You can also visit us at soilhub.org. We have a newsletter that goes out every quarter, and we'll also be sending out information about the events on that listserv. So please feel free to sign up for our newsletter. We send out resources and funding opportunities and learning, reading, educational type things. So with that, I am going to say a huge thank you to all 3 of our speakers. Really wonderful presentations, so much great information, and we will have the recording available afterwards too. I'll share that out with everyone who's here today, and that'll also be posted on our website as well.